All right, so here's a basic circuit problem that asks to find the equivalent resistance between the point A and the point B. So the best way to go about this is figuring out what is in series and what is in parallel. The best way to do that is just by looking. So obviously these first two resistors we know are in parallel with one another. It could go this way or it could go this way. It doesn't always go through both. So that is how you know that they're in parallel with one another. And then as we know, when we're adding parallel, 1 over the equivalence is equal to 1 over 1.5 plus 1 over 2.5. However, we still have more to take into consideration. As we know, it would be really easy to solve this question if it looked like this, this, and this. If we just had that 6.3, that would be perfect. Because what we would do is if this was 1.5, this was 2.5, and this was 6.3, we would just do 1 over the equivalence, which is what we're looking for, is equal to 1 over 1.5 plus 1 over 2.5 plus 1 over 6.3. However, we can't do that because we have a whole clump of stuff here. So first, we're going to get this together before we even deal with these two guys. So this 4.8, this 3.3, and this 8.1, they're going to be in parallel with one another, meaning it goes here, or it could go here, or it could go here. However, this entire thing together is in series with the 6.3. So if this was just a 3.3 and we didn't have these guys, then it would just be 3.3 and 6.3 in series, which are in parallel with these two, right? So we need to combine these so that we can combine these so that we can have 3 separate things that are in parallel with one another. So I'm going to start with just deconstructing this because that's the simplest way to go about this problem, because our 1.5 and our 2.5 already look good, as in they are in parallel with one another already. So let's work out these guys here, and then we're going to implement this, and then we're going to implement that to everything to find the equivalent resistance. So because these are all in parallel, it would be 1 over 4.8 plus 1 over 3.3 plus 1 over 8.1. And that's equal to 1 over the equivalence of just these 3 here. So we're going to do that quick because we know if they're in parallel with one another, this is our formula. So we're going to do 1 divided by 4.8, 1 divided by 3.3, and 1 divided by 8.1. Then we're going to add these guys up. And then we're going to take the inverse of that, and then we have our equivalence. So this is our equivalence, 1.57. So what we can change that to, or how we can now look at that, is what we basically did is because we added those, we have our 1.5 still, obviously. We have our 2.5. This has now been changed to 1. And then the 6.3 is still something. So what we just solved for is this, 1.575 is our new units there. So now we're one step closer because we've broken this apart. These added together in parallel is this. So now we have these two in series before we can have 3 in parallel with one another. Because right now, this is in parallel, this is in parallel, and then this whole thing's in parallel, but these are in series within this final parallel. So what we're going to do is, how do we add series? 6.3 plus 1.575. We'll just put that in there. 6.3 plus 1.575, 7.875. So now we're looking like this. Which is exactly what we wanted. But this is 7.875, and then these remain 1.5 and 2.5. So now we have 3 things that are in parallel with one another to find the equivalence. So all we have to do is 1 over 1.5 plus 1 over 2.5 plus 1 over 7.875, and that's equal to 1 over our equivalence. And our equivalence is our answer. So we're going to do 1 divided by 1.5, 1 divided by 2.5, and 1 divided by 7.875. Add add inverse, and our answer is 0.8377, so we're on to 0.84, and that's our total equivalence. So to briefly kind of go over what we did is this is our starting problem. We said, hey, this problem is going to be really easy if this is in parallel with this is in parallel and this is in parallel. However, we have this big chunk that we need to implement within itself, and then we need to implement it with this 6.3. So what we did is we implemented this into one by adding them in parallel, because these three are in parallel with each other. Now we just have one here, 1.575, that's what we got, and then we have 6.3. Obviously these two are in series with one another, so we needed to add these in series to get our 7.85. So then we have it with just 1.5 in parallel with 2.5 in parallel with 7.875. Added them in parallels to find the total equivalence and got our equivalence of 0.84 between the point of A and B in our circuit.